Hello class, and welcome again to our next discussion on chemical nomenclature. Again, we're dealing with naming inorganic chemical compounds. Last time we dealt with naming covalently bonded compounds. Now we're dealing with naming ionic compounds. So again, remember that ionic deals with a metal with a nonmetal. And covalent deals with nonmetals with nonmetals. And that's a key that you distinguish between the two, and that's why we emphasized that so much last chapter, and identifying the difference between those kind of bonds. It's going to become very important in terms of naming, because there is a slightly different naming procedure between each one. There's a lot of similarity, but there is some difference. Now, in quick review, we said that with naming a covalent bond, what you're going to do is you first want to identify how many of each element, or how many atoms of each element you have, and you use the Greek prefix to identify that. So if you had 2, then it would be bi. If it would be 3, it would be tri, and so on and so forth. And you guys are in the process of learning those. So that would be the first thing that you do. And then with a covalent compound, then from there, the next thing, whatever the first element is, the one with the positive oxidation number, which is the one that will always be written first, will then get its full name. So whatever that is, whether that's chlorine or phosphorus or whatever, it gets its full name just right off the periodic table. And then whatever the second element is, or the last element in a binary compound, then you're going to drop the ending and add IDE. And again, that's after you put the prefix, the Greek prefix for how many there are. So it might be, trioxide, or, pentafluoride, or something like that could be the case. And we kind of went through that last section. Now what we're going to do is deal with ionic bonds and kind of quickly cover the basic rules for ionic bonds. And again, we're naming binary ionic compounds, which means 2. And this means 2 elements, and one of them is going to be your metal, and the other one's going to be your nonmetal. So, and you're going to see them on opposite sides of the chart. What's the separating line again? It's that stair step on your periodic table that kind of separates the metals on one side and the nonmetals on the other. And so as you're looking at that, I'm going to have some of those partnered. Now today, when we're dealing with binary ionic compounds, we're mainly going to be focusing on the alkali metals and the alkaline earth metals mostly. The transition metals and some of the post-transition metals we're going to kind of mostly deal with in a separate section, because most of them have dual or more than that oxidation states. In other words, they can have multiple oxidation numbers, and as a result of that, then the naming procedure, there's something else we have to add to it. Everything we say today is going to still apply to the transition metals, but then we're going to add one other thing to that, because most of them have more than one oxidation state or number, and we'll kind of explain more details of that as in class. One of the things that we want to start with is the rules for binary ionic compounds. So since there's only 2 elements that we're dealing with, it's fairly simple, and it pretty closely follows the covalent compounds, with one kind of exception, and that exception is it actually makes it easier to name ionic compounds, and that is kind of this first rule here. The first rule is you don't use the Greek prefix system when naming ionic compounds. That only is used when naming covalent compounds. So covalent compounds, you have to identify how many there are. If there's 2, it's bi, 3 tri, so on and so forth. 4 tetra, 10 deca, so on and so forth. But with an ionic bond, you don't do that. And the main reasoning behind that is quite simply that when you have an ionic bond, if you remember, we talked briefly about that it's a ratio. Remember, we spent some time dealing with the ratios, and that ionic formulas are written in the lowest whole number ratio. It's simply a ratio of how many atoms of this do you have, of your metal, do you have to your nonmetal. That's what it is. And it's not that you have this particular metal is bonded to this particular nonmetal. It's a ratio between them, and so we don't necessarily use the Greek prefix system in there. which actually is one less thing that we have to do. So it just kind of simplifies everything. So rule number 2 is kind of getting us started on the naming process. So knowing that I'm not going to identify if I have 2 or 5 or 10 of those particular element or atoms of that particular element, then I'm not going to identify it. So the first thing I'm going to do, the metal is always named first. It's always written first. And so I'm going to name it first, and whatever comes first is going to receive its full chemical name. So the metal always gets its full chemical name right off the periodic table. So if it's sodium, it's going to be sodium. If it's potassium, it's going to be potassium. If it's magnesium, it's going to be magnesium. If it was iron, it would be iron. Okay, so on and so forth. So there's nothing I need to do, nothing I need to change. I'm going to take that first element, give it its full name. That's it. Period. End of story. Once I've named the metal, then I'm going to move on to my non-metal. Again, I'm not using the Greek prefix system. Make sure that you emphasize that in your notes, because every year there are students who mix that up and they use the Greek prefix system with ionic bonds and not with covalent bonds, and they kind of get confused between the two. So make sure that you really emphasize that. So now I get to my non-metal, my second element that's written in my compound, and the non-metal is going to be named by dropping the ending and adding IDE. So almost kind of the same thing that you did with covalent bonds. Whatever the second item is, or the second element is that's named, you're going to drop the ending and add IDE. And it's going to be very, for like a lot of the halogens that end in INE, you're just going to drop that INE and add IDE. So it becomes, instead of fluorine, it becomes fluoride. Instead of chlorine, it becomes chloride. So those are really easy. Oxygen and sulfur are a little bit different, but hopefully by now you're kind of getting the hang of it. Oxygen becomes oxide, sulfur becomes sulfide, nitrogen becomes nitride, phosphorus becomes phosphide, so on and so forth. Okay, those are the main ones that we will use as we go through and combine them with metals, but that's basically how it works. So it's real easy. So kind of just to quickly sum it up, the metal always gets its full name, and the non-metal, you drop the ending and add IDE. So let's take look at a few of these and see how they work. So let's start with this one right here. We have calcium and fluorine bonded together. You notice we have 2 fluorines and 1 calcium. We do not need to worry about the Greek prefix system. So we're not going to use mono and di, all that kind of stuff for the Greek prefixes. Instead, we're just going to name the metal. Metal always gets its full name. That was our rule. So our metal is calcium, so we're going to name it calcium. And then we're going to come over to our non-metal, which is fluorine. We're going to drop the ending and add IDE, so it just becomes calcium fluoride. We're not going to put in the di or anything like that. So our name is just simply calcium fluoride. That's it. We're done. I don't need to do anything else to it. Move on to the next one. This one here, I have, again, 2 elements, and I recognize, hey, this is an ionic bond because I have a metal, I have an alkali metal combined with a non-metal. My alkali metal, in this case, I have 2 of them, but that doesn't matter because we're not going to use the Greek prefix system. So I have potassium, I have 2 of them, doesn't matter, just going to name it potassium. Remember, the metal gets its full name, and then the non-metal is sulfur, and I'm going to drop the ending for the non-metal and add IDE, so I have potassium sulfide is my name for that one. Let's try this next one, see if you guys can get this next one here, and then we'll check and see if you're correct. I have a metal and a non-metal. Try it on your own real quickly. I'll give you a second or two to do this. All right, it shouldn't take you too much longer than that. As you're looking at your periodic table, and I'll talk again here for a second if you need to finish up naming these. But again, especially if you have your periodic table with you, it shouldn't take real long to name these ionic compounds. You should be able to do it in 5 to 10 seconds, at the most, because all you're doing is looking at your metal. Metal gets its full name. Non-metal, you drop the ending and add IDE. So it should be fairly quick, especially since you're going to have your periodic table with you. The first one there is sodium. It doesn't matter that there's 3. We're not going to use the Greek prefix, so I simply say sodium. And then the other one is nitrogen. I'm going to drop the ending and add IDE, and so it becomes sodium nitride. And so hopefully that's what you got. and that would be the correct answer. And so if that's what you got, then it seems like you've probably got the right concept. We will do more in class, and I would like you to, before you get to class, try this one, and when you arrive, we'll see if you got the correct answer. Here with this last compound, I'm not going to tell you in the video here what the answer is. We'll do that in class, but I would like you to practice that at home real quickly. And again, it should only take you 5 to 10 seconds if you're using your periodic table to check and see whether you've got that correct. I will see you in class.